representation of data. Under this representation of data, we are learning about the histograms. Histogram means, you know that when you're just like a similar to a bar chart, what is the difference between a histogram and a bar chart is, when you draw a bar chart, you can keep a gap between the bars. But histogram is used only for continuous data. Therefore, you cannot keep a gap between bar chart unless there are no information. If you come up with this example, you can see there are no information from 0 to 1.5. That is the reason there is no bar has already drawn. Other than that, you cannot keep a gap between these kind of bars over here. That's the difference between a histogram and a bar chart, right? Then when you draw a histogram, children, we know that in our small grades, we have already learned the y-axis as the frequency, and the x-axis is the what you call set of data mentioned over here, right? But if this, what do you call that, class widths are not similar. What do you mean by class widths? So if you come up with this example, here the width is how much? The value, the width over here is 25 to 30 is 5. Here the width also 5. Here the width is 5. But here the width is how much? It's 10. And here it's turned up to 30. If these widths are not similar, we cannot draw a histogram. Again, straightforward, we cannot draw the frequency in your y-axis. We cannot draw the frequency in your y-axis. In that case, we will draw the frequency density. We have already learned this in our O levels or IGCSE. How to calculate the frequency density? The frequency density is calculated by the formula frequency divided by class width. For example, if you work out over here for this question, the frequency is how much? Frequency is 55. Frequency is 55 and class width is how much? 5. How to get the class width? 30 minus 25 is the class width. Then 55 divided by 5 is 11. Therefore, we can mark, like rather than that marking 55 over here, 55 in the y-axis, we will mark 11 over here. That is the simplest definition of drawing the frequency density. If you come up with the second example, frequency is how much? 39. Class width is how much? Class width is 5. Therefore, the frequency density is 7.8. So rather than that mark in the y-axis at 39, we will mark 7.8 in y-axis or the frequency density axis. If you come up with the next category, here the frequency is 68, class width is 5. Therefore, the what you call frequency density turn up into 13.6. Then we can mark 13.6 in the y-axis for the category of 35 to 40. 40 to 50 class width is 10. Then 32 divided by 10 is 3.2, right? Okay. Then what you can understand is we can mark 3.2 in the y-axis, right? Okay. Then in this question, in a random sample of 200 students are asked how long it took them to compare their homework, complete their homework in previous night. The times were recorded and summarized in the table below. So that is how it mentioned. Draw a histogram and frequency polygon to represent this data. Right. How to represent this data? Later on we'll come up with how to draw the frequency polygon. Then initially let's try to draw the frequency, what you call histogram or frequency density graph. Like later on we'll come up with how to do this estimation. So if you come up with the next diagram. Right. Here, children, you can understand that the frequency densities are 25 to 30 is 25 to 30 is 11, 30 to 35 is 7.8, 35 to 40 is 13.6, 40 to 50 is 3.2, 50 to 80 is 0.2. So we will mark this information. Let's see about here. The first category is 25 to 30. It's 11. 25 to 30. 25 to 30, it's we have already marked as level. So you can mark the bar like this, right? Then here 30 to 35 is 7.8. So if you go ahead here, 30 to 35, it's 7.8. It's almost close to it, so you can mark it as 7.8. The next category is, sorry, the next one is 30 to 35 to 40 is 13.6, so you can mark 13.6. So on, you can mark this information over here. Right. Then children, that is the way of you can draw this information. Then our problem is how to draw the frequency polygon. The frequency polygon you can mark very easily. What you need to do is join the midpoints of the corners of the these bars. So you can get the each in this histogram bar. This is the bar over here, and this bar is already here, and this bar already over here. Like that, mark the midpoint. So what is the midpoint over here is this point. The midpoint over here is this. The midpoint over here is this. Midpoint over here is this. And midpoint over here is this. Then you can mark these points. That follows up a frequency polygon. That is how you need to draw the frequency polygon using a histogram, right? The next part is the most important section, right? We know that children, frequency density equals to how much? Frequency divided by class width. Then if you cross multiply, what do you get? Frequency. Frequency is equals to frequency density into class width. Frequency density is which length? The height over here. Class width is this length. If you multiply this length by height, what do you get? You get the area of this rectangle. You get the area of this rectangle. Then if you want to find the frequency in this column, in this category, what you need to do? You need to find the area of this rectangle. That is the simple way of identifying that, right? Okay. Then the next question is they are referring to estimate how many students took between 36 to 45 minutes to complete their work. Let's go to the diagram. That is 36 to 45. That means if you want to find the number of people who's in this category, what you need to do is you need to find the area of this polygon, this bit, the shaded area over here. You can find the shaded area over here plus area over here to get the total number of information, right? Then how do you get the area over here? We know that here this is 36 to 40. What is the gap? Gap is 4. Gap is 4. And this height, we already knew that. For this category, height is how much? 13.6. Therefore, you can mark 4 into 13.6 to get this area. 4 into 13.6 into this area and this gap. Here the gap is 40 to 45 is 5. And this height is how much, children? The height is 3. If you work out over here, you can say the height is how much? Height comes in, sorry, it should be 3.2, not 3. 3.2. Then you can mark up with 3.2 into 5. With that, you can get the number of information. 70.4 students represent in this frequency polygon. That is how you need to understand over here. Right? Okay. Let's move up to the next question. Right. In the next question, what they request is the histogram below display the information gathered from 100 people regarding how long in minutes they took to complete a word puzzle. Right. Then the first question they ask is why we should use a histogram to use this represent this data. What is the reason for this? But then you can understand that all this information, it's a time. Time fact is a continuous time, continuous information. Continuous means there is no difference between that. We have already learned in discrete random variable. What do you mean by the continuous data? For a continuous data, we can draw a histogram. Since this information is continuous information, you can draw a histogram for this kind of data. That is why we used to go ahead with the histogram to draw this information, right? The next question is, write down the underlying feature associated with each of the bar in the histogram. We already learned that if you get the area of the bar, that represents what? That represents the frequency. So the property of this each bar represent, if you get the area of the bar, that would be exactly similar to the frequency of this information, right? That is a feature you can understand by area of a bar, right? Given that 5 people completed the puzzle between 2 to 3 minutes. Now let's come up with this 2 to 3. Here it's 5 people have completed this one. So that means this area represent 5 people. Find the number of people who completed the puzzle between 0 to 2. Let's see how to do it. Then you can see that this area represents the frequency. Then how many small boxes over here? You can see in this over here to here. There are 5, here to here 5. That is 25 small boxes represent how much? 5 information. There are over here 25 box represent why it is 5, because it's mentioned 2 to 3, it's 5 people. That means this area is 5. Over here the area is 5. Then there are 25 small boxes over here. If you get 5 information represented by 25 boxes, means each small box is each small one, this much of a small stuff is similar to 5 divided by 25. It's 1 over 5. So the each small box is 1 over 5 or 0.2. Then they ask about how much of information they are from 0 to 2. Now see whether how many small boxes are there over here. You can see here to here there are 10, and here to here there are 2. 10 into 2 is 20. That means there are 20 small boxes over there. Each box is how much? Each box is 1 over 5. How do you get 1 over 5? From the previous case, from this area proportion, we get that. So you can get the answer 20 into 1 over 5. There are 4 people over here. So that means 0 to 2, there should be 4 people in this category. That is how you need to understand to do this question. Right. Let's come up to this question. Right. Okay. In this question, what they say is the data in the table show is a mass in kilograms of 50 adult puffer fish. Over here, that means if you understand this information over here would be 10 to 15, there are 4 information. That means there are 4 puffer fish in the age category of 10 to 15. There are 12 fishes in the category of 15 to 20. 23 in 20 to 25. 8 in 25 to 30, so on it goes like that, right? Then they ask about draw a histogram for this data. Then when you mark in the draw like histogram, first make sure whether these class widths are same. If the class widths are same, you can mark the class width over here, and you can straightforward mark the frequency in the y-axis. But if the class widths are not similar, you cannot draw the frequency in your y-axis. Instead of that, you have to mark the frequency density in your y-axis. Here the class width is 5. Here the class width also 5. This one also 5. This one also 5. And this one also 5. In that case, you can, if you want, you can mark the straightforward frequency in your y-axis. Right? But apart from that, if you want, you can mark the frequency density also in your y-axis. For this case, it's not a problem because the class widths are similar. But if the class widths are not similar, definitely you have to mark the frequency density in your y-axis. For this case, not a problem. If you want, you can draw the frequency density instead of histogram, right? Okay. But anyway, in this question, we will go ahead with the frequency density graphs because that is the most frequent information where we need to handle with, right? Okay. Then, if you calculate the frequency density for the first category, what is that value? The frequency is 4. The frequency is 4, and class width is how much? Class width is 5. Then 4 divided by 5. 4 divided by 5 is 0.8. Here the frequency density is 0.8. Then we can mark 10 to 15 as 10 to 15 as 0 0.8. 10 to 15 as 0 0.8. Then 15 to 20, 12. Then 12 divided by this one also it should be divided by 5. 12 divided by 5 is 2.4. So you can mark 15 to 20 is 2.4. It's 2.4 over here. Then 20 to 25, 23. 23 divided by 5 is 4.6. So you can mark 4.6 and you can mark the rest of it. After that, on the same set of axes, draw the frequency polygon. How to draw the frequency polygon? Get the midpoint of the first bar, midpoint of the second bar, midpoint of the third bar, midpoint of the fourth bar, and midpoint of the fifth bar, and you can mark the midpoints. Is that clear, children? Hopefully you can understand how we supposed to do this kind of a question, right? Okay, let's go to the next question. Right. Some students took part in an obstacle race. The time for each student to complete the race was noted. The results are shown in the histogram. Give a reason to justify the use of histogram to represent this date. What is the simple answer for that? The simple answer is, since this is continuous data, you can draw a histogram to represent this set of information, right? Then let's come up with this. 90 students took between 60 to 70 seconds. Then 60 to 70 seconds, there are 90 students. Yeah. Then find the number of students who took between 40 to 60 seconds. Now, to find it, you know that this is a frequency density graph. Area represents the frequency. They have mentioned that 60 to 70, there are 90 students. That means this area represents how much? This area represents 90, 60 to 70 area. This area represents 90. Then you can see from this category how much of small boxes are there. I'm trying to find out this area using these small boxes. You can see here to here 1, 2, 3, 4, 5 boxes. There are horizontally 5 boxes. Vertically how much? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 into there are, sorry, 5, yeah, 15 into 5. So in that case, you can say, sorry, 1 second. There are in 5 and yeah, in upwards, there are 5, 10, 15 boxes are there. Vertically, there should be 5 boxes, hopefully, yes. 1, 2, 3, 4, 5. 5 into 15. 15 or 12, let's 1 second. 5, 10, 15. So you can mark up like this. So you can say there are, oh, other than that, you can straightforward using this frequency density category as well. If you get like, if you mark the boxes, it should be each box represents 90 divided by, so if you get this here, I prefer to use this way. Hopefully we will try to find out, yeah, doesn't matter, okay, right. Horizontally, there are 5 boxes. Vertically, there are 15 boxes are there. There are 5 into 15 is how much, children? That is 75. The 75 represents, the 90 student represent by 70 boxes. So if you divide 90 by 75, each box is how much? Each box would be 1.2. So if you get the area of a small box, one small box, that would be 1.2, right? They have used a different, what do you call that, scale for that. Right, but we can use the say what you call whatever the scale what we have used over here. So yeah, in that case, one small box is 1.2. Yeah, let me see what the scale they have used. It's 90, 10 into 6 into 60. Right, doesn't matter. We will use our scale, not a problem. Then find the number of students who took between 40 to 60 seconds. Then we know that one small box is 1.2. Then we want to see 40 to 60. 40 to 60 is over here. How much of how much of small boxes are there? Vertically, how many of them there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 into upwards we have 5, 10, and there are 10, 11, 12, 12.5. Seems to be 12.5. Then if you mark 12.5 into 10, 12.5 into 10 is how much, children? 12.5 into 10 is 125. Then you have to multiply this 1.2 with 125. Then if you work out 1.2, so 1.2, if you multiply with 125, you should get the answer 150 information. Let's see whether this answer is fine. Yeah, that is 150 students are there in that category. Here it's 150 students are there in that category, right? Okay, then let's come up with this, right? Okay, find the number of, yeah, the next question is find the number of students who took 80 seconds or less. Look at this, 80 seconds or less. Then 80 seconds or less means we have to count up entire area over here, this one, and this one, right? We already knew the number of information over here is how much? That is 150. We already found that value, 150 in this category. Here you have 150. Here we know that there are 90 students. Altogether 150 plus 9. Here there are 150 information. Here there are 90 information, altogether 240. Then we need to find the number of information is in this category only. This one only we need to find out. Then how do you find the value over here? Now count the number of boxes remaining over here. Vertically you can see there are, horizontally there are 5 boxes. Here there are 1, 2, there is 5, 10, 15, 20. This should be 21, 21.5. Then you have 21.5 over here, 21.5 multiply with, vertically there are 5 boxes, 5. Then each box is 1.2, then multiply with 1.2. So you will obtain the answer 129. Then you can add 129 into 90 plus, here we already count as 150, and you can get the final answer over here. Yeah. So this is how it comes. 369 comes into this category, right? Okay. Then they ask about estimate the how many people threw less than 25 meters. Yes. Then 25 meters. Sorry, it's a wrong question, right? Calculate what they want is they want calculate the total number of students who took part in the race. Yeah. Then yes. 1 second. Calculate the total number of students who took part in the race. That means what you need to find? You need to find the total area over here. And how to get this area, you can work out. We already know the frequencies over into these 3 columns. Simply we can get that. And we can identify the area over here, and area over here. And if you add them together, you can find the total number of people who took part in the race. Right? That is how you need to do this question. In this question, a fun day committee at a local sports center organized a tennis ball throwing competition. The distance thrown by every competitor has recorded, and the data is shown in the histogram. 40 people threw ball less than 20 meters. Then you can understand, children, they mentioned 40 people threw ball less than 20 meters. That means this area would be 40. This area would be 40. Then we can understand that, yeah, the first question what they ask is Why is a histogram suitable to represent this information? The simple answer is, since this information is a continuous data, this is much suitable, right? Okay. Then they ask about, so from the first fact, we know that 40 people seem to bowl less than 20 meters. That means this area is, this is the what do you call that fact which is related to less than 20 meters, right? Okay. Then we know that this total area should be 40. Then how many boxes over here, Pratik? So you can see there are 5, 10 over here, 5, 10, 10 into 2, 20. 20 boxes represents 40 people. Yeah, 40 people. That means what is the value of a small box? The value of a small box should be 2. How, if I repeat it back, there are 40 boxes over here. Sorry, there should be, sorry, 5, 10, 20 boxes. 20 boxes are there. It represents 40 people. That means one small box represents 2 people. Right? How many people enter to the competition? Then we need to see whether how many total boxes over here. Small boxes, and we can count the value. Let's try to work out. Yeah. Here you can say area of this is already got to 2 people. So you can say the total area. Let's see. 20 into 2. Here there are 20 into 2. Right. Next one is, sorry. Next one is 15 into 5. Let's see. Here this is 15 from here to here and height is 5. 15 into 5. Then again 10 into 10. Let's see. Here. This is over here. So in that case, you can work out with the total area. So just so, yeah. So you can do 20 into 2, 15 into 5, 10 into 10, 15 into 6, and 5 into 1. Let's see whether this is correct here. This is 20 into 2. Sorry, there should be how many boxes over here? 10 into 2. Sorry, I made a mistake. It's at the same fact they have used, but they have used a different different thing, right? It's rather than that we do doing this way. So it's much easier if you use this technique. So what you can understand here is you can, there are two methods you can use. First method is we can count the value of a small box, and then after that we can work out. It's a different technique. Means like we can get the first way what we can do is we can count the boxes. Here to here there are 10 boxes. 10 into 2 is 20. 20 represents 40 people. Therefore, each box represents 2 people. Then we can count the total number of boxes over entire diagram, and we can find out we can get the count over here, the total number of boxes in this platform over here, here to here, then multiply with 2 and you can get it. That's the first thing. Oh, other than that, we know that here they have mentioned this width is how much? This width is 20 and this width is 2. This height is 2. So if you get the area over here is how much? 20 into 2 is 40. 40 means it represents 40 people. That means each square represent how much? Each square represent 1. Then we will count the total area over here. If you count the total area over here, that is 20 into 2. 20 into 2 is the area over here. Here the area is 15 into this is obviously it should be 4. So you can get just like this 4.55, 5.56. So that so this is come up with here to here there are 6. The half of that's 5. So you can get count it as 15 into 5, and from here you can count it as here this is 35 to 45, 10. 10 into this is actually not 10. So this should be 10, 10 into 10. So here the gap is 10 and here the height is 10. Then you can work out 10 into 10. That's the second, that one. And over here this is 45 to 60. That is 15. 15 into 6. 15 into 6 is over here. 15 into 6. And here the count is 5. 5 into 1. You see here. This is 20 into 2. 20 into 2. Then 15 into 5. 15 into 5. Then here 10 into 10. Let's see here. 10 into 10. Okay, right. The next one is 15 into 6. Let's see here. 15 over here. So 15 into 6. 15 into 6. And the last category is how much? It's 5 into 1. Let's see here. 5 into 1. So there are how much of total squares are there? There are 310 squares over here. There are 310 squares over here. What is the value of one square? What is the value of one square? We already found it as how much? It's as 2. So you can multiply 310 into 2. You can get the total figure as 620. That is how you need to get that value. Right. In part C, how many limb did the question C. Estimate the people, how many people threw between 30 to 40 meters. 30 to 40. It's over here. 30 to 40. That means we need to find out the area. We need to find the area from here to here. 30 to 40. 30 to 40. That means you have to find out this area plus this area over here. This total area. Then multiply by, let's see. Then if you work out over here, 30 to 40. 5 into 5 plus 5 into 10. Let's see whether this is correct. Here, this gap is 5. This height is 5. 5 into 5 plus this gap is 5. 5 into 10. Then 5 into 5 plus 5 into 10. It's 75 squares are there. 75 squares are there. One square is 2. Therefore, totally how many people over here? There should be 150 people should be in that category. That is how we need to work out. Right. Okay. How many people threw between 45 to 65 meters? 45 to 65. It's over here. Yeah. 45 is here. 45 is here to 65. It's here. We need to find out the area over here and multiply with the scale of a one box. Let's see. Here you can say 45 to 65. There are two categories. 15 into 6 plus 5 into 1. Let's see. 15 into 6 plus 5 into 1. Then how many boxes over here? There are 95 squares. Each square is 2. Therefore, there should be 190 people who have drawn this object. Right? Okay. Then let's come with the part E. Estimate how many people through less than 25 meters. Less than 25 is which area? From here to, sorry, this is 30, somewhere here. Here to here. The total area enclosed by this bit. 25 less than 25, that bit. Over here to here. Right. Then we can work out the area over here. Area over here is how much? 20 into 2. 20 into 2. Right. Area over here is how much? This is 5 into 5. 20 into 2 plus 5 into 5. There are 65 squares. Therefore, each square represents how much? 130 people. 130 people. There with that, you can say the number of people who is get less than 35 meters would be how much? Should be turned up into 130 people. That is how you need to do that question. Right. Let's go on to the next part of it. Right. A farmer found the mass of a random sample of lands. The mass was summarized in the grouped frequency table and represented by a histogram. The frequency for the class of 28 to 32 is 28 to 32 was 32. 28 to 32. See whether this category over here. This category was 32. Show that 25 small squares on the histogram represents the leaf. Right, okay. Now let's try to count out this question, right? Part A. They mention for the bar of 28 to 32, the area is 10 into 10. Let's see. Here you can see, here to here there are 10 boxes, and here to here there are another 10 boxes. Altogether, how many boxes here? Altogether, there should be 100 boxes. This 100 boxes represents 100, yeah, Here, if you work out in this case, just 1 second. Yeah. Over here, here to here, there are 100 boxes. 100 boxes represent how many information? 32 information. 100 boxes represents 32 information. Therefore, each box represents 32. Sorry. So you can say what happened here. So then after that, they ask about 100 squares. 100 squares represent 32. Then what we need is they ask about show that 25 small squares represent 8 leaves. So 32 represent 100 squares represent by 32. That means 25 squares should be 1/4 of that. 1/4 of 32 should be how much? It will turn out to 8. Then that means 100 represent 32 means 32 represent by 100 means 25 should represents 1/4 of that. 25 is 1/4 of 100. Therefore, 1/4 of 32 should be 8. So it shows us 25 small squares represent 8 lamps. Right. Okay. Then let's go to the next part of it. Find the frequency of the 25 to 26 class. 24 to 26 class. 24 to 26 here. 24 to 26. Now let's see how to work out. Right. We know that 24 to 26 contains 5 into 20, 100 squares. Let's see whether this is correct. Here to here, 5. Yeah, here to here the gap is, sorry. So we can work out 5 into 20. Let's see whether this is correct. This is 5 and here there are 20 squares. You just count over here, you can say 20. If there are 100 squares, then we know that 5 the frequency. See, 100 squares, we know that 100 squares is how much? 100 squares represents 32. We already knew from the previous section. 100 squares is how much? 32 lamps. So the value over here should be how much? 32 lamps, right? Okay. Let's go to part C. How many lamps did the farmer wait in total? That means you have to count out the total area over here and mark with the value of it. Let's see. 20 to 24, there are 100 squares. 20 to 24 here, 100 squares over here. That means there are how many lamps? There should be 32 lamps in this category. Right. Then 24 to 26, let's see. 24 to 26, there are 100 squares. There are 100 squares, therefore in that category even we can see 32 lamps. Right. Then 26 to 28, here, the total area over here. That is 5 into 40, there are 200 squares. We know that 100 squares is 32 means 200 squares should be how much? That should be 64. Then 28 to 32. 28 to 32. 28 to 32, there are 100 squares. That means there are 28 lamps. 32 to 34. 32 to 34, the area is 25. We know that 25 squares is how much? 25 squares represent 8 lamps. So altogether, if you add them together, you will obtain how many lamps? You will obtain 168 lamps over here. Right. Then let's come with the part D. Estimate the number of lamps that has mass between 25 to 29. That is from where to where? From here. 25 to 29. It's here. So you need to count the area over here. Yeah, we need to count the area from 25 to 29. Let's see. 25 to 29. This total area we need to find out. Over here to, if you come up over here, it's here. Right, okay. Let's see how to count that. Right, okay. We know that 25 to 26, approximately half of this, right? We know that 25 to 26, right? Look at this. 25 to 26. You can say this is the 25 to 26, half of this graph. No? So that means it should be the half of the area over here. We already knew that how many information was there. In that category, there was 32 information. We already found from the previous section here. There are 32. That means in this category, there should be how many lamps? There should be 16 lamps remaining in this group, right? In the next category, 26 to 20, sorry, 26 to 28. This one here, we already know that that entire bar above the count, it already we can count that what do you call number of lamps in this total column. That amount is 26 to 28. We already found from the previous section. There are 64 lamps. There are 64 lamps. Then 28 to 29. Let's see. 28 to 29, you can see 28 to 32 is the full category. That should be 1/4 of this part. Should be the 1/4 of this part. Then we can work out 1/4 of how much? 1/4 of the information over here was how much? There was in that 28 to 32, there are 32. 1/4 of 32 is how much? Here, you can see here there are 32 lamps. 1/4 of this bit. The reason is that 28 to 32 is a 1/4 of this gap. Therefore, you can work out 1/4 of that category should be 8 lamps. Altogether, 16 plus 64 plus 8. There should be totally 88 lamps in that category. That is how you need to do it. I will start with this fifth question. In this fifth question, they mention the partially. Yeah, in this fifth question, I mentioned the partially not entirely completed histogram shows the time in minutes that passengers were delayed at the airport. Copy and complete the table. It's over here. You have to find out the copy and complete the table. Right. Okay. When you work out the completion, you can understand, children. Now we need to find out, because this scale is not completely mentioned, it's just only the number of boxes mentioned over here. Let's see whether how to find out a relationship between this graph to this table. We know that here the frequency is how much? Here the frequency is 4 and the class width is how much? The class width is 20. Then if you divide 4 by 20, that answer is how much? 0.2. That means this height is how much? This height is 0.2. So this is 0.2, 0.4, 0.6, 0.8, 1, 1.2. So on it goes on, right? Okay. Then we need to find out the number of information from 20 to 30. This is this category. Okay. What is the reading over here? This is 0.2, 0.2, it's 1. Obviously, this the same, it's mentioned. What you call the mention, the scale is same thing, but doesn't matter. Whatever the question, you have to work out in that way and make sure whether that scale is correct. Sometimes it might be given a different scale over here, right? Okay. Here, this is 1. 1 into what is the gap over here? 10. 1 into 10. So there should be like 1 into 10. That is the what you call that the frequency over here is how much? Frequency over here should be 10. No need of working out with these things, just this optional stuff, right? Because we need to fill up this category and this category. If you want, you can draw these ones and work out. Other than that, this is not essential. These two categories are not essential for this calculation, because like we need the sorry, this is essential for the calculation, but no need of marking as a final answer, right? Okay. The next category is 50. See whether now 30 to 35, that's 50. So we need to mark this diagram. 30 to 35, it's up to here. Up to here. 30 to 35, right? Let's see how to do it. Now you can say that 30 to 35 gap is how much? Gap is 5. Then 15 divided by 5 is 3. Then you have to draw a bar up to 3. You have to draw a bar somewhere like this, up to 3. I will show you from the next diagram. Here you have already drawn up to 3. Is the answer for that. From here to here, draw a bar up to 3. So you can say it's frequency density, so you can mark a bar over here, right? Okay. Then we need to find out 35 to 40, 25. 35 to 40 is 25. That means what is the frequency density? Frequency density is 5 divided by 5, 25 divided by 5, that is 5. Then you can mark here, it's 5. Over here up to 5, you can mark this bar. That's what you have to do it. Right? Okay. Then the 40 to 50. 40 to 50, we know that here the gap is 10 and here the height is almost like 0.2. We know that one box is 0.2, 0.2, 0.4, 0.6, 0.7. 0.7 into 10. 0.7 into 10 is how much? That should be turned up to 7. The frequency must be 7, right? Let's come to the last one. Last one is 50 to 70. Here, 50 to 70, the gap is 20 and height is how much? Here 0.2 and 0.3. Here 0.2 up to here, it's not come up to 0.4, should be 0.3. 0.3 into 20, it's how much? That is turned up to 6. So that is how we have to fill up this information up to 6. That is the way you can do this question. Okay, let's move to the next question, right? Okay. Now, this is another very important question because this is one of a exam style question where we can observe and we need to understand the approach for this question. Right? Let's see. The variable y measure the nearest whole number. 60 observations were taken and are recorded in the table. 10 to 12 is 6. There are 6 information in the category of 10 to 12. Then there are 24 information in the category of 13 to 14, 18 from here and so on. Right. Then write down the class boundaries for 13 to 14. What is the use of identifying a class boundary? Working out with this, right? You cannot keep any gap between these ones. So if you work out over here, when you draw a histogram, you cannot keep a gap between the bars. So when you draw a histogram over here, you will mark it as 10 to 12, one group, and again 13 to 14. There is no, there would be a gap generates between 12 to 13. But when you draw a histogram, you can't keep a gap as it is. Therefore, we need to define a class boundary for these ones. How to do it? Here to here, the gap is how much? 12 to 13. The gap is 1. Then gap, that 1 divided into 2. Then how much you get? 1 divided into 2 is 0.5. Then stretch this from 0. From 13 to lower side, bring it 0.5 to lower side. Then it will turn up to how much? 12.5. 14 drag to the greater side 0.5. Then how much of it? To turn up to 14.5. So this will turn up to 12.5 and this will turn up to 13.5. This one also you have to do the same. If you do it, how much? What do you get? 9.5, 12.5. The gap should be, the gap of 0.5 should be brought to the lower side and to the greater side. This is 9.5 to 12.5. This is 12.5 to 14.5. Sorry. Then this is 14.5 to 17.5. This is 17.5 to 25.5. Right? That is how to do it. From 13 to 14, the gap should be 12.5 to 14.5. Right? Okay. A histogram has drawn and a bar representing 13 to 14 class had a width of 4 centimeters and a height of 6 centimeters. Find the bar representing 15 to 17 class and find the width and height. Now let's see how to do it today. Then we know that, let's work out with this category. The information given is 13 to 14. 13 to 14 children, the width, let's discuss about width. What is the width from here, 13 to 14? That is, we already define it as 12.5 to 14.5. The width is how much? 2. Actual width of the bar is 2 and we need to find the width of 15 to 17. 15 to 17, if you stretch this bar, what is that? 14.5 to 14.5 to 17.5. What is that width? Actual width is 3 centimeters. Here the actual width is how much? 2 centimeters. Actual width is 2. Here the actual width is how much? Actual width is 3. Then this actual width of 2 represented by a length of how much? They mention the histogram bar drawn is represented by width of 4 centimeters. Here the width is 2 centimeters. Width of 2 is represented by 4 centimeters. Width of 2 represented by 4 centimeters. Then we want to find out width of 3 represented by how much? Width of 2 represented by 4 centimeters means width of 3 represented by how much? Obviously that should be 6 centimeters. Hopefully you can understand. Okay. Then when you're discussing about height, children, right? You know that when you draw a histogram, since the class widths are different, definitely we need to draw the frequency density graph. That means the height. Height is always frequency density, right? Here the height is how much? 24. What is the width over here? 2. 24 divided by 2. Then 24 divided by 2 is 12. So obviously, here the height is 12. That one keep it in your mind, right? Now let's try to calculate what is the height over here, right? Here the gap is 3. 18 divided by 3. 18 divided by 3. 18 divided by 3 is how much? 18 divided by 3 is 6, right? Here the height is 12. Here the height is 12 and here the height is how much? Here the height is 18 divided by 3. Sorry, 6. 12 and 6. Now 12 is represented by a length of height of how much? 12 is represented by a height of 6 centimeters. Then this is the height is how much? Height is 6 centimeters, 6 more. So 12 is represented by 6 means 6 is represented by how much? Obviously that should be 3 centimeters. If I repeat it back, here the height is 12, here the height is 6 when you draw the frequency densities. 12 is represented by a height of 6 centimeters. Therefore, what you call height of 6 should be represented by half of this. Therefore, that you can work out over here. That is how you need to get it.